All right, problem number 4. When a positive 3-digit number with a units digit of 2 is divided by a positive 1-digit number, integer, I guess it says, the result is a whole number with a remainder of 1. How many distinct values are possible for this 3-digit number? All right, well, this one, I don't know if there's an easy way to do it. It just takes some just careful thinking and some sort of systematic approach to it. And you really had to keep track of what you're doing here. So let's just write out what we've got here. We've got a 2-digit number, so it's the first 2 digits, and then you know that the units digit is 2. And you're dividing it by a 1-digit number. Okay? So let's just we could say this digit is A, this digit is B, and let's just call this digit C. Okay? So we know that, we multiply here, and then we get something here, and then we subtract, and then we get something here, and then we drop the 2, and then we multiply again by something else, and then subtract, and we get 1, so we get a remainder of 1. Okay? So the key here is to think in terms of, okay, if you got a remainder of 1, then you know that if you had 1 less, if this number, this AB2, was 1 less, then you would have a remainder of 0. So then you would know that it was evenly divisible by whatever the single digit number is. So, okay, let's write that out. So we have AB1 divided by C. Okay, and we know that that is going to have a remainder of 0. Okay, because we just took away that remainder. So we subtracted 1 from the number, and then it's a number that's evenly divisible by whatever the single digit number is. Okay, so whatever it is, it's got to have a 1. You got to be able to multiply it by something and get a 1 in the units digit, right? So let's take a look at all the numbers that end in a 1. Well, of course there's 1, there's 11, there's 21, there's 31, 41, 51, 61, 71, 81, 91. So, and if you look at these numbers, you can recognize a lot of them are prime, right? So we'll cross out 1 because it's not prime, but it's also not a composite number either. So, because we know it has to be a composite number, because we're going to take this number times something and then subtract, so whatever, we're going to get a remainder of 0 down here, right? So so it's got to be some digit with a 1, and it's got to give us a remainder of 0. That means whatever we multiplied it by has to end in a 1. So it has to be a composite number. Alright, so 11 is not a composite number. 31 isn't. 41 isn't. Now 51, you can tell, is a composite number because the digits add up to 6, which is divisible by 3. So this is actually equal to 3 times, 17? Okay, and 21 is equal to 3 times 7, okay. And then 61, that's prime. 71, that's prime. 81, okay, 81 we know is equal to 9 times 9, or it's equal to 3 times 27, and then 91 is prime. Alright, so given that, we know that we have to be dealing, since this is this number that we're dividing by is a single digit, then it has to be either a 3 or a 7 or a 9. Alright? So we're getting more information. We're just sort of analyzing what we've got and to see what we can do with what we know about this problem. So, well, 3 and 9, that's not too bad to evaluate. Because if this number is evenly divisible by 3 or 9, then the units or the digits will add up to something that's divisible by 3 or 9. Okay? So let's take a look at what that would have to look like. So we add up these digits. So we have A plus B plus 1 has to give us something divisible by 3. So that means that that would be have to be 3 or 6 or 9 or so on. But that also means that A plus B has to be 2 or 5 or 8 or 11 or 14. Okay, just one less than a multiple of 3. Okay, so let's take a look at what. Okay, so if we have the first two digits add up to 2, what could the numbers be? Well, we could have 2, 0, 1, right? Or we could have 1, 1, 1, okay? And those should all be divisible by 3, okay? Alright, so let's look at 5. If the first two digits add to 5, then we could have 501, we could have 141, 2, 3, 1, 3, 2, 1. We could have 4, 1, 1, and that's pretty much it because we already have 501. Alright, so let's look at the case where the first two digits add up to 8. Alright, so we'd have 801, that's one case. We could have 171, we could have 261, we could have 351, we could have 441, we can have 531, we can have 621, or we can have 711. And that's it because we already have 801. Alright, so let's go through the case with 11. We can have, let's see, the 291 would be the smallest we can get. And then 381, 471, we can have 561, we could have 651, we can have 741, 831, and 921. Okay, and that looks like it's it. Alright, so let's go to 14. 14. We could have 591, 681, 771, 861, oops, and 951. And let's take a look at 17. We can have 891 or 981. And that's it. That's all we can do. We can't, we could look at 20, but we can't get two digits that add up to 20. So, so that's all we can do. Now we can count those up. We have 2 here. We have 5 here, 8 here, 8 here. We have 5 here and 2 here. Okay, so looks like we have a total of 30 here. Alright, so that takes care of 3 and 9. Now we need to look at 7. Now there isn't a nice easy rule for 7, so 7's a little trickier. Not as if that wasn't tricky, but 7's even trickier. So but again, it's just a matter of really just being really systematic. So let's take a look at let's take a look here. Now, if it looks like the only two-digit number that is not prime and involves 7 is this 3 times 7. So we know up here we'd have to have 7, and this would have to be 21. Okay, and then we get 0. So this has to be a 2. So that means whatever is here, okay, has to be 2 less than whatever AB is. So so we have some multiple of 7, because here we're dealing with a case where C is 7, all right? And actually I think I did that wrong. So if we're dividing by 7, 7's our single digit number that we're working with. And so we're dividing by 7. Actually, this should be a 3, right? So divided by 7, sometimes 3, that gives us 21. And then we subtract 21, and we get 0. So this multiple of 7, so I could just write it like this. That looks kind of funny, but so this, it has to be AB minus 2, all right? In order to be able to subtract that and get 2, then it has to be 2 less than whatever AB is. Okay? So, let's look at the multiples of 7, and then actually, you know, then we can, if we just add 2 to both sides, then AB has to be equal to whatever, it has to be equal to a multiple of 7 plus 2. Alright, so let's look at the multiples of 7 and add 2. And then see how we can see what numbers we can come up with that are different from these numbers over here. Alright, so look for part 2 for the rest of this problem.